Hello and welcome to my video presentation. My name is Chelsea Fountain and I will be presenting for Biochemistry Week 5 for the group advanced presentation. In this presentation, I will talk about each stage step by step involved in generating ATP, NADH, or FADH2. There are 4 stages of cellular respiration. For the first step in glycolysis, glucose, a 6-carbon sugar, undergoes a series of chemical transformations. In the end, it gets converted into 2 molecules of pyruvate, a 3-carbon organic molecule. In these reactions, ATP is made and NAD plus is converted to NADH. Next is pyruvate oxidation, where each pyruvate from glycolysis goes into the mitochondrial matrix, which is the innermost compartment of mitochondria. There is converted into 2-carbon molecule bond to coenzyme A, known as acetyl coenzyme A. Carbon dioxide is released and NADH is generated. The third step is the Krebs cycle or the citric acid cycle. The Krebs cycle or Krebs cycle consists of 9 enzyme catalyzed reactions that can be divided into 3 stages. The acetyl coenzyme A, made in the last step, combines with a 4-carbon molecule and goes through a cycle of reactions, ultimately regenerating the 4-carbon starting molecule. ATP, NADH, and FADH are produced and carbon dioxide is released. With step 4, oxidative phosphorylation, the NADH, excuse me if I pronounce any of these wrong, the NADH and FADH2 made in other steps deposit their electrons in the electron transport train, turning back into their empty forms, NAD plus and FAD. As electrons move down the chain, energy is released and used to pump protons out of the matrix, forming a gradient. Protons flow back into the matrix through an enzyme called ATP synthase, making ATP. At the end of the electron transport chain, oxygen accepts electrons and takes up protons to form water. In conclusion, glycolysis can take place without water in a process called fermentation. The other 3 stages of cellular respiration, pyruvate oxidation, the citric acid cycle, and oxidative phosphorylation, require oxygen in order to occur. Only oxidative phosphorylation uses oxygen directly, but the other 2 stages can run without oxidative phosphorylation. Sorry. Next, I will talk about the 3 steps on how 30 ATP are formed. The conversion rates from NADH and FADH2 to ATP are: NADH yields 2.5 ATP and FADH2 yields 1.5 ATP. In the glycolysis stage, ATP yields 2 ATP, 2 NADH plus H plus reduce FAD to 2 FADH2 yields 3 ATP. The conversion of pyruvate to the acetyl coenzyme A, no ATP is produced in this stage. However, the 2 NADH plus H plus yields 5 ATP. In the citric acid cycle, 2 coenzyme A molecules yield 2 ATP. NADHD plus H plus is produced 6 times from the 2 acetyl coenzyme A yields 15 ATP. 2-FADH2 from the 2-acetyl coenzyme A yields 3 ATP. This is how 30 ATP are formed. Thank you. This concludes my presentation. I hope you guys enjoyed it. I'm sorry for mispronouncing it, the words that I did, and have a good time. Have a good night.